Those are our number line numbers, no decimals, no fractions, full like whole kind of numbers. So we've got to be over 6, can't be 6 because there's no equal sign. We got to be more than 6, but it's not like 6.1 is not possible. We've got to bump up to 7. So 7 is the one side of the rectangle. What's the other side then? Because there's 2 sides to this rectangle. 7 is the side we know to be x. So who's the other one?
7?
No.
10.
10, why?
Because it's 3 more.
It's 3 more. So our answers would be 7 for one and 10 for the other. 7 for the width, 10 for the length, something like that. But we would need to mention a 7 and a 10. If this were a money question and I took away the integers, integer word out of play, were more than $6, how much money is the lowest you could go?
$7?
No. $6.01 would be the lowest we could go. What if I went like that? What's the highest you could go? $5.99. That wasn't a money question, I'm just giving you what it is. So 8. 8, we're looking at this. So what's that about? Is there a reason to do single thing there?
No.
No, it didn't say the most pens, the least pens. It didn't say any of that. So we're going to go phrase. Less than equal to phrasing.
No more.
No more than can work. So we could say no more than 6. 6 what?
Dollars.
No. What was the
Cents?
X?
Pencils.
Pens or pencils?
Pens.
Pens. The X was the pens. We had a 30X, so the X was that 30 center thing. The X is the pens. So we could say no more than 6 pens. Then what would be our pencil count? 11. Why 11?
Because she buys
5 more. So no more than is the phrase because of the sign. 6 pens because that was what X represented. 11 pencils because the pencils were 5 more. 9, 10. We have this. So here's a thing about repairmen that you might not know. But generally speaking, if a plumber shows up at your house and works for 8.6 hours, they will charge you for 9. What if they worked 8.2 hours? They will still charge you for 9. If they worked for 8 hours and 1 second, they'll charge you for 9. Hello? Alright, yeah, I'm not interested in exchanging my car and I'm in the middle of teaching a math class. So, yeah, I know, I'm good. Thank you. Alright, bye. Yep. No, I like my Honda. I don't want to trade it. My wife's getting her car fixed today. And so I thought that might be like a call I wanted. But they're like saying, this is the Honda exchange coordinator because our cars are in pretty good shape. But no, I'm going to drive my Honda till it falls apart. Alright, but yeah, if they work 8 hours in 1 second, they'll charge you for 9 hours. Okay, so what number here would you have to make this true?
11?
11. You couldn't have like 11.1 because they'll charge you for 12. Okay, so we have an 11 for this. The answer though is not, wait, yeah, okay, we would need to have that be an 11, that's true. But that's not the answer. Does anybody spot a loophole in this one as to why that won't be the answer?
Doesn't divide you.
No. It had to do with the strange payment structure. Who's the X measuring?
Is it only 50 once and 30 a bunch more times?
The X is measuring the count of the 50s or the 30s?
30s.
The 30s. How many 50s are we going to have to pay for before we get any of the 30s?
One.
One. Okay, so what we have going on here is we can at most get like 11 of these, but we still have to pay for one of the other ones. So that would be 12 hours or less is what we want. For 11 solved correctly looks like this. So what we want to say, what phrase can we use for this? A phrase that works for greater or equal to?
No less than.
Okay, so we could say no less than 250, and that was the 4% investment. How about the 6% investment? How much would that number be? I'll tell you it's 750 because the bell's coming. How do I know it's 750 now that you see that number?
Subtract from 100.
Yeah, it was $1,000 total dollars. So if we know it's 750 a one, or excuse me, 250 a one, it has to be 750 of the other one. So hopefully that's helpful. We're like a few seconds till the bell, so that's all we really have time to do. What we're hunting tonight is page 2. We're up to 215. So 215, we're looking to go 1 to 12. Tomorrow we just answer homework questions, and then I'll give you a sheet that's due 2 days away before we run away. We can cut that off. Okay, so we're in 5-8, so instead of going to the board, we're working from a sheet of notes. So we're just looking to see if we can write ourselves an inequality, which means the equal signs are out, graders and lesses and things like that are in. So number one is telling us a story. Can anybody get anything cooking in terms of creating a problem that we can solve?
You can do 440,000 minus 80,000 divided by 10.
You're a step probably down the road thinking about all your opposites and stuff to undo this, which is good, but I think it's gonna confuse more folks. So I'm gonna say you're right, but I'd probably rather go a different direction.
Is it 80,000 times 10 equals 440,000?
It's something in that neighborhood, yes, but not quite that. Which number's gonna go by itself on one side? Let's try that. The 440,000 is a total. So let's go 440,000 all the way to the right. That's a grand total of a bunch of stuff. How are you gonna get the grand total figured out of this bunch of stuff?
You're gonna do X or whatever number times 10.
We are gonna do an X times 10. We know that there's a big shot guy making a lot of money, and then there's 10 guys that are equal, but we don't know what the 10 equal people are. So there is a 10X, yes.
Minus 80,000?
Not quite.
Plus.
A plus 80,000. The 10 employees are making some money. The president's making some money. We add all that money together, that's gonna get us our total money. So we're gonna go 10X plus 80,000, a symbol that is not
Equal
equal sign. Your test is up here somewhere in these stacks. And then a 440,000. So the question is, should we be greater than that amount of money? Should we be more like less than that amount of money? Less than that amount of money, because that's the amount of money we have to spend in our budget. You can't go over that or the company's going to go out of business. Could you equal that amount of money? Yes, you could. So we're going to go less than or equal to sign. So we'll go 10X plus 80,000 less than or equal to 440,000 And depending on how much time we have, we'll go through some of these and solve them, but I don't know if we'll have time to set up and solve all these questions. So let's set that one up and then let's just move on for a second. Question about setting up one? Okay, 2. 2 is a little easier to write because we can just kind of like go through this and just do a number or word at a time. So the first number or word that matters is 300. The next word or number that matters is plus. The next word or number that matters, 2%. How should we change 2%? 0.02. Then we see the word of, which means to multiply. The sales, which we don't know. So that's X. Then there's at least is a code word for a certain sign. So let's come back to that in a minute and do the 390 at the very end. And then let's talk sign. If we have at least 390, or you're probably over it or probably under it? Probably over it. Can you equal it? Yes. If you're at least 390, that means you're like 390, 391, 392. It's 390 or more is another way to say that. So we'd go greater than or equal to. 300 plus 0.02x greater than or equal to 390. Question about how we're creating 2. 3. We've got grades on 3 tests that we know. We have a next test that we don't know. What do you think you should do to those numbers before we even read beyond that? If you have 3 tests that you know and a test that you don't know, what math does that feel like you should do to those scores? We're going to average them. To average them, how are you going to do that? First, you'd add them up. So we'd go, I just wrote 92 plus 89 plus 94, and then what else? Plus X. I just wrote that all. Then how do we do the average after? It says we're doing an average, so how do we do an average once we add it up? Divide. So I'm going to go big long fraction bar. So my top is the 92 plus 89 plus 94 plus X. The bottom would be 4. Leave a gap for the sign that's coming, and then the last number is going to be 90. And then I asked it 2 ways. The first question I said at least 90. So what symbol would we use? The greater than or equal to sign for that one. Then I do a change of question, and I'm going to do the exact same thing running back, and we'll solve these if we have time to do. If I change the question to just say average greater than 90, how would that change your sign? Just straight out greater than. So at least means greater than or maybe equal to. Greater than just means greater than. So we'll come back around to that. There's going to be 2 answers for that problem because I kind of asked it 2 ways.
Okay.
Yeah, so we'll get back at that one. 3, 4, something about creating. So 92 plus 89 plus 94 plus X, all on the top of a fraction bar, 4 on the bottom, and then greater than or equal to 90. And then when I go to do plan B, I'm just going to go straight out greater than 90. Something about that. 5 is another one that we can kind of, it can't quite read it and do it quite as well as 2 did, but well, we could go after this. So we've got 2 jobs for this guy, 80 bucks at one job. The other job is 9 for every hour, but we have no idea how many hours he works at his other job. So what can we do to figure out how much money this guy is going to have?
80 plus 9x.
80 plus 9x is true, where the x is like how many hours he worked. Leave a space for a sign for a minute, and then the obvious number to go at the very end is 152. Then it's just a question of what symbol to do. If we're no less than, that's another way of saying we're not less than. That's greater than or equal to. If we're not less than it, we're either greater than it, probably, or maybe there's a small chance we're equal. So we'd want to go greater than or equal to sign there for that one, for that creation. Question about that? let's skip to the back. So on the back, what do you think we ought to do for this story as soon as you start to read it?
Draw a rectangle.
What'd you say?
Draw a rectangle.
I agree. Draw a picture of some sort. So it's a little hard to picture all this, but draw ourselves a rectangle. It says the length is 3 more than the width. It doesn't really matter which one you consider to be the length or which one you consider to be the width, because rectangles can go like this anytime they want. Okay, so if you got real like OCD about, no, that one's the length, sorry, because now that one's the length, I guess, in your world. It doesn't really matter. Okay, but one of these is longer. One's longer by 3, one is shorter by 3. We don't know what any of them are. So there's a couple ways you could label this picture. Somebody have an idea?
Plus 3 on the bottom.
What plus 3?
X plus 3.
We could go x plus 3 for the long one, and then the short one, no. Because if we make one of them x minus 3 and the other x plus 3, how far apart are they then, really?
Not really.
How many numbers apart? If one gains 3 and one loses 3, they're 6 apart. They're not 3 apart. We need these numbers to be 3 apart. That's just an x. So if this is just an x, this is going to be 3 more than it. What if you wanted this to be just your x?
X minus.
Then this could be x minus 3. That's both okay. It doesn't matter. But most people would rather add. What's this one then? Another x. This is another x plus 3. So that's what we can do for picture-wise. If one's 3 more than the other, something like that. Then it talks about the perimeter. What's the perimeter about? Is that the inside or is that the around? That's the around. So how far is it around this shape?
4x plus 6.
4x plus 6 is true. So 4x plus 6 is in here. Then it says more than. So that sign is
Greater.
just straight out greater than, no equal to, got to be more than 30. So 4x plus 6 greater than 30. Something about that. So let's skip down one. We're buying some pens for 30 cents. We have no idea how many. So what would you do about the money just for that? We're buying, they're 30 cents a pen, and we don't know how many pens we're buying, but we're trying to figure out how much this costs us.
An X.
Something with X. 30X. We would want to take the cost of every one pen times the pen count. And we don't know the pen count, so we'd want to go 30 times X. We're also buying some pencils. So the math there suggests after we figure out our pen money, we're going to have to figure out our pencil money and do what with it? Add it. So 30X plus. We're doing pencils. It's going to be 20 times something, but not X. If we did an X, that would suggest that our pen count and our pencil count are the same, but they're not. The pencil count is
Some pencils.
how many pencils?
X.
No, keep reading.
5 more.
5 more than the pens. So the pens, we already went with an X. If the pencils is 5 more, what's that?
20 plus 5.
No. Pen count is X, pencil count is 5 more. So the
25.
pencil count is,
Be either do Y or X plus 5.
well, we're committed to X. So if the pen count is X, the pencil count, if it's 5 more, is X plus 5. We need 20 to multiply X plus 5. What's that? What are we going to need to make that look right? Parentheses. So we're going to go 30X for the pens plus 20, and then have in parentheses X plus 5 for the pencils. Finish line number isn't going to be just plain old 4. Why can't I just get away with a plain old 4 at the end? Because I see a 4.
No more than.
Well, we'll do the sign in a minute, but there's something about the 4.
Dollars.
It's got to do with dollars versus what were the earlier prices, cents. So if we were treating 30 cents as 30, and we're treating 20 cents as 20, how are we going to have to treat the $4?
400.
400. So 30x plus 20 wants to distribute x plus 5. A symbol we'll get in a second, and then a 400. For the symbol, which word phrase is going to give us our greater than less choice? No more than. So in other words, it's not more than. What symbol are we going to use if it's not more than? Less than or equal to. It's probably going to be less than, but there is a chance it could be equal. So we'll go less than equal to then.
So what's like the end for that then? Like the,
So we're 30x plus 20 wants to distribute x plus 5, less than or equal to a 400.
okay, thank you.
Rewind anything?
That's good.
910, a lot of repairman stuff works this way. For them to even come and look at your problem, whether they're coming to your house or you're going to their shop, sometimes there's like a upfront, we're going to charge you, in this case, $50 for the first hour. So whether we fix it, whether we don't care. For us to even bother with you, you're going to pay us $50 for the first hour. After that, if we decide we're going to dive in and actually do this job, we'll go $30 for every hour after that. A lot of plumbers are like that. It's not $50 either. It's more like $100. You call a plumber and you're like, I have a plumbing problem. They're like, that's fine. We're going to show up at your house. That's $100. That'll get you an hour. And beyond that, we're going to charge you something else. It's usually cheaper for the something else, but they charge you a big money thing for your first hour, and then they change after that. But this repairman, we're going $50 for the first hour, $30 for each hour after that, but we have no idea how long they're going to stay and work. So what can we do for that math?
50 would be plus
Yes.
30x.
Yes. So the 50, we're paying one of it no matter what. So there's no variable or multiplication or whatnot. The 50 is one of a kind. But the 30, we're going to pay this guy 50, and then 30, 30, 30, 30, 30, 30. As long as he stays, it's another 30 every hour on the hour. So we're going 50 plus 30 times x. Finish line end number would be the
Less than 410.
410, and it is a less than because it says the bill is under. So we can't equal 410, it's under 410, so that's a straight out less than. Something about that one. Then we're going to do one more that's kind of like the cookies. If you remember this, where I'd say like, I have 10 cookies, I give Aaron 2, so Izzy gets
8.
8. I have 10 cookies, I give Aaron X. It leaves Izzy
10 minus x.
10 minus X is correct. So on this story, I have $1,000. I'm going to put X of it in this investment. That means I'm going to put
1,000 minus x.
1,000 minus X in the other investment. The one investment is 4%, so we're going to change 4% to
0.04.
0.04. The other one is 6%,
0.06.
0.06. So here's how 1112 is going to go. We're going to take a 0.04 times an X. So 0.04x for this world. We're making money here, we're making money there. What do you think we want to do to our monies? Money here, add them together. So we're going to add up our money to figure out what our total is. So 0.04x here, do a plus. For these to multiply, how's that going to have to look?
Like line it up, put a decimal at the end of the 1,000.
Then not necessarily. For this to multiply, 1,000 minus x.
Oh, when you're done multiplying it, move it over.
Yeah.
Decimal.
If I'm going to show it's multiplying though, how would I show that? That I'm multiplying this times this.
A dot.
I could, parentheses is what I'm hunting for there. For this to multiply all of that, we'll need all of this in parentheses. So we go 0.04x plus 0.06 parentheses, 1,000 minus x. Hang on for a second for the symbol. The last number will be the 55. If we're at least 55, is that probably more or probably less? If we're at least it. More. And can it be equal if we're at least it?
Yes.
Yes. So at least is code for greater than or equal to. if you want to jot down somewhere in your notes or on this page or something, anytime it's at least, that's going to be greater than or equal to. Anytime it's at most, you'd use less than or equal to. If we say no more than, which one was that? If it's no more than, not, in other words, not more than, wait, not more than, less than or equal to is true, yes. No more than is the less than equal to world. So no less than is,
More than.
which symbol? If we're no less than?
More.
Greater than or less than equal to? Greater than equal to. So at least is greater than or equal to. No less than is greater than equal to. And then the opposites. No more than is less than equal to. At most is less than equal to. That might be something good to have in your notes to look at in case you forget that and you have a place you can peek and get it. That's phase one. Phase one is get these problems set up. That's going to cause you some problems because that's new. We haven't done that much, and that trying to translate life to math is sometimes a difficult adaptation. Anybody need some help about how we did that? Okay, phase two is going to be the easiest phase of this. Phase two is just going to be that you're going to solve it. So I'm going to kick this into fast forward mode. So back to, let's go in reverse order. If you solve 12 right, it would take some distributing and combining like terms and things that we've done, but I think we could do it. If you don't think we can do it, I'll double back if there's time and we'll do some of these on the board. But just to make sure we have our info, 11 is going to be x greater than or equal to 250. Just jot that down and we need to come back for phase three. But phase two is solving this. So x greater than or equal to 250 is 11's solve. 9's solve would be x less than 12. X less than 12 back on 9. Back to 8 would be x less than or equal to 6. X less than or equal to 6. Back to 6, it would be x greater than 6. X greater than 6. Anybody need a description of the back? While we're on the back, does anybody think you would not be able to solve something and I could coach you up a little bit on how I'm just quick saying the solves? Would anybody have anything there you think would stick you of opposites and that stuff?
What was the answer to 9?
Answer to 9 is x less than 12. Anybody see anything that would intimidate you to solve? Okay, so let's go back to the front. 5 would be x greater than or equal to 8. X greater than or equal to 8. 3, let's talk a little bit about 3. So the first thing I would do to solve 3, since it's a big division problem, I'd multiply. So I would turn that 90 times a 4 into a 360. And around that same time, maybe first or second, I'd add all the numbers together. So here's a reworked number 3. It would be better looking if it were 275 from adding, plus an x still, greater than or equal to a 360 from doing an opposite, 90 times 4. But that's much more solvable. The solve for 3 is x greater than or equal 85 is the final answer. X greater than or equal to 85. Back to 2, it's x greater than or equal to 4,500. X greater than or equal to 4,500. Back to 1, it's x less than or equal to 36,000. X less than or equal to 36,000. And then we'll pause. So again, phase 1, you have to translate from English life, real life, to math life, algebra life. Phase 2 is what you're probably best at, is just solve. Do your opposites, all that kind of business. Phase 3 is where you're going to struggle again, because we don't do this a lot, and that's to translate back from math into what this real world situation is. And we're going to have to answer the question that we're asked, and we're going to need to make like some little adjustments to these numbers here and there. Sometimes they want one answer, sometimes they want two. Like that pen pencil thing, we probably wanted 2 answers, not just an answer. Things like that. But question about the phase 2 solves it all? Okay, so now we've got to interpret. So the first thing you want to scope out is, are they looking for one answer, or are they looking for like a lot of possible answers? So this is like an English issue of singular or plural. So on this, it just says, how much can we spend? How much could we do? So does this have just a single answer, or are there a lot of ways this company could pay these people and stay under 440,000?
There's a lot of ways.
There's a lot of ways. So what we need to do is come up with a phrase that expresses something like, there's a lot of options to this. So the sign is going to be your key again. So with a less than or equal to sign, what's one of the word phrases that works for that setting? Less than or equal to.
No more.
No more than could work. So one right answer could be no more than 36,000, and that would be a win. What's another way we could say it? At most 36,000 would win. Does everybody have to use the same phrase? No. Other people could say 36,000 or less. That would work too. But you need some kind of phrase, because there's a lot of answers, so we need a phrase that communicates. Lots of choices here, but no more than 36,000, at most 36,000, 36,000 or less. Do you have to write them all? No, you just pick one that works, and we can agree to disagree if we like different ways to phrase that. Something about that? Okay, so 2, Louis sold a bunch of stuff. He's trying to make a lot of money selling his stuff. Is there one set amount of stuff that he could have sold, or are there a lot of possible things he could have sold here?
A lot.
There's a lot. So we need a phrase that suits this. So look to the sign and let the sign dictate your phrase. So greater than or equal to sign, what kind of phrases could we use?
At least.
At least 4,500 is a win. No less than 4,500 is a win. 4,500 or less, that's a win. Pick one. Any of those work. You just have to get it translated back to an English phrase. At least 4,500, no less than 4,500, 4,500 or less, whatever that might be. 3 only has one possible answer, because it came out and said, what is the lowest? The, in that case, is a strong word. The gets ignored a lot. That's a word that just kind of blends into your paragraphs and it doesn't matter. But if we say, what is the best, the worst, the whatever, that's a strong word. That is a single choice. Okay, it's the difference between me saying, hey, what movies do you like? You might give me a bunch of movies that you like. But if I say, what is the movie you like best? Now there's one answer. That's it. The top movie in your life. When I start saying the, we got one. Okay, so if the first way we wrote this was with a greater than or equal to sign. So if we're looking at this, if I say name me some grades that this kid could have had, what's a possible grade we could have that makes this work? 100 works, because it's more than or equal to 85. What's another one that works?
86.
86 works. 90 works. Lots of them work. Okay, so if I said to you, what grades work? You could name a lot of them. But I say on this question, what's the lowest grade that can work?
86?
No, we can go lower than that.
85.1?
We could go lower than that.
85?
We could go 85. Because it's greater or it's equal. So if we want to go how low can we go, 85 would be the answer. No word phrase necessary this time, but a little bit of thought necessary. We just say 85. 85 is the lowest grade that we could do for that question. But then there was a part B. For part B, we would have had that sign. Does 85 itself work?
No.
No. So what would work? What's the lowest you could go to still make this true?
86.
86, you could argue for 86. I could see 86, I would score that as correct. How about on one of my tests? What do I do that some teachers maybe
85
don't?
and a half.
Maybe 85.5. I do some half points. So you could argue for 85.5. 85.5 would be a winner, but I think that would be your two things that you could argue about depending on your teacher. Some teachers don't give half points. You know, if you have a matching test, if this is a matching test, this answer is 86. But if you've got a math test where maybe reducing a fraction cost you a half or something, 85.5 would be an argument. But that time we had to stay over the 85. So either 85 and a half, 86, something like that. Question there. Okay, for 5. Is there a reason to pick out one single answer, or is 5 like, hey, it's got a lot of choices again?
It's a single answer.
It is not. Because what didn't it do that 3, 4 did? What was my magic word on 3, 4? The. And not just the, but the highest, the lowest, the best, the worst. If we have the something in the question, we go that direction. This one, it's a plural because it said how many hours, exaggerated S. That's a definite plural word because we got the exaggerated, I just exaggerated it, but the S at the end of the noun in the question. So how many hours? There's lots of choices for how many hours this kid could work. So go phrase. Greater than or equal to? What's a phrase for that? At least 8, etc., so forth. Lots of options there. Question about interpreting the front. 6. If solved correctly, 6, we're looking at this. Is there a reason to go single answer? Or are we going to go phrasey?
Single.
Single. Where's it? Why single?
Find the minimum.
The minimum. The minimum means go as low as we can go. So, what's the lowest number you can do that makes this true?
6.
No. No. No.
6.
No. No. Give me a number that makes this true.
7.
Yes. Another number that makes that true.
8.
Yes. Another number makes
9.
that. Yes. What's the lowest number makes that true?
7.
Yes. Why not 6.1? 6.1 does make that true. Why is 6.1 not a thing here?
It's not an integer.
It's not an integer. It says these dimensions are integer.